Okay, so E looks like we want to integrate. Oh, we're not integrating, frankly. So we want to resolve 5x squared plus 10x minus 12 over x cubed plus 4x into partial fractions. And the first thing again is to recognize the degree. The numerator is 2, degree of the denominator is 3. So we're in that perfect situation. Otherwise, we will have to divide if the degree of the numerator is greater than the degree of the denominator. We make a division before we try to resolve partial fraction. So in this case, though, we need to go ahead and factorize. So I put on my blue cap for factorization. First thing we can do is take out the x. We get x squared plus 4. We have to resist the temptation to try and factor that because it doesn't factorize. This is what people like to call irreducible. So it's irreducible over the reals. So we don't factorize it. So the technique though say if we have such a situation going, then we have a over the linear factor plus, this is what we call a quadratic factor, and the prescription is to have bx plus c over x squared plus 4. Again, if we can factorize the quadratic factor, let us say it was x squared minus 4, then we would factorize that as x minus 2, x plus 2, and now we have linear factors. But this cannot be factorized. So you have to be careful. They will always try to sneak one on you where it cannot factorize, and you will factorize it. Okay. So, and this technique that we're going to use is what we used before. There are lots of techniques. There is even techniques where we can differentiate, if you can believe that. That's a nice application of calculus, and find these ABCs. So again, I'm going to work on the numerator from this side. Let's switch to my purple pen. The numerator from this side, what's that? What does that become? It becomes a into x squared plus 4. This is where my formula for fraction becomes super important. Bx plus c into x. This is so important, I'll write my formula down again. A over b plus c over d is equal to what, guys? What is a over b plus c over d?
Is it AD plus C times B over B times D?
Over bd. Very important. All right, that's my formula. Very important, and that's what I'm using here. So I'm using a times d, b times c. Right? Is that good? I'm just interested in the numerator, so I'll just keep that. And this is going to be equal to 5x squared plus 10x minus 12. It's important that you think on this because many students come out of high school totally, well, not even high school, it's, well, I guess you leave high school eventually, but many students are totally confused about fractions. That's the first problem on my calculus class. First day, I give a diagnostic test, and that's the first problem, to add fractions. So let's go. Again, we're using the technique we used last time. We combine this side. This gives me ax squared. Notice there is a bx here. Well, let me write it in 2 lines. 4a plus bx squared plus cx. And this is equal to 5x squared plus 10x minus 12. So I want to combine the left-hand side to have a plus bx squared plus cx plus 4a. See? And then on the right hand side, I have 5x squared plus 10x minus 12. And so in this case, what do I have? I can compare the coefficients of x squared with x squared. It says a plus b equals to 5. X with x says c equals to 10. No worries right there. And then here it says 4a, so it says minus 4a. Oh, sorry, 4a is equal to minus 12. I will take that out. So this is just 4a is equal to minus 12. And then I go and I solve. I know c is equal to 10. No worries there. A would be equals, this implies a is equal to what? Minus 3. Is that good? C is equal to 10. And if a is equal to minus 3, and then I could tell you here that that b is going to be equal to what? 8. B is equal to 8. Is that good? So that's what we have going for us there. And then what do we do after that? Finally, well, let me again write it in this spot, because otherwise I can't see what I have there. Finally, I want to go back and I want to say, therefore, what? 5x squared plus 10x minus 12 over x cubed plus 4x is equal to total resolution into partial fraction. It gives me a, we said, was minus 3 over x. B, we said, was 8. So this becomes 8x. C, we said, was 10 over x squared. And you have to be able to do this